Okay, we have seen the definition. Now let's look at the application. Okay, okay, x is distributed binomially, or x is binomial distribution. Okay, therefore you have the number of size, or the how many what's the population, and then the success, okay, p. Whereas the blue line or the curve over here represent, change color, x is a normal distribution, okay, and whereby you have np as the mu, or which is the mean, and then variant as npq. Okay, np as the mu, which is the mean, and then npq as the variant. Okay, so therefore if you have that, okay, then I can approximate binomial distribution, okay, the probability, to using normal distribution. Okay, how do I do this? Okay, we have looked at continuity correction. Okay, so now how it's applied. Okay, this is what we're going to have a look now. Okay, let's say I have binomial distribution. Okay, before that, binomial is a discrete variable. Okay, discrete variable. What's a discrete variable? It's countable. Okay, it's a countable variable. For example, okay, how many days that you were absent, okay, from school. Okay, you can be absent for 5 days or 6 days, a month. Okay, if you have any chronic illness, okay, that's a countable variable. Okay, so we know it's a fixed value. The other thing is how many number of siblings that you have at home, 4, 3, 2, blah blah blah. Okay, so that's a discrete variable. Whereas when I approximate from discrete to continuous variable, it's a measurable variable. For example, height of a person, okay, 1.75 cm, or number of stars in the space, okay, because it's uncountable. Whereas in discrete variable, I can say number of planets, okay, in the orbit, I mean in the planet system, number of planets, that's countable. So far it's countable. Okay, so that's what continuous term is. Okay, now let's look at what happens. Okay, discrete variable, let's say we have x is a binomial distribution with n and p, and let's say p is probability of finding x equals to 5, okay, in discrete variable. Then what is the probability that we are looking at? We are looking at the probability when x is 5. That's it. Okay, that's discrete variable, it's a fixed value. Whereas in continuous term, okay, we can approximate this to 5 between two different limits. Okay, how do I get 5? Okay, what is the lowest number that I can have in continuous term which will give me 5? It's actually 4.5. That's the lower bound that I'm talking about. And then the highest value that I can have that gives you 5 will be 5.5. So in continuous term, when I talk about x is equals to 5, then I'm talking about between these two variables, or these two limits, which is between 5.5 to 6, 4.5 to 5.5. So instead of us writing x equals to 5, then it should be x less than 4.5 less than x is less than 5.5. So this is what